Alright, let's look at the homework 7.5, 7.6, problem number 12. Alright, so we want to find the distance, minimum distance from the circle to this given point, 0, 19. Alright, so let's do that. Alright, so let's see, we want to minimize this function right here. Alright, so this function right here, so this is going to be our little f of x comma y, right? Then you have a constraint. So this is a constraint. So I'm gonna we have to rewrite this guy as by subtracting 25, we have quantity x minus 6 squared plus y squared minus 25, right, is equal to 0, right? So this is our g of x comma y. So right here, g of x comma y, right? So what we can do is we can just construct the capital F function, which is just x squared plus quantity y minus 19 squared minus lambda times g of x, which is, let's see, I have to put the square bracket here, x minus 6 squared plus y squared minus 25. Alright, so let's take the partial derivative. So partial of capital F with respect to x would be 2x, and derivative of that is 0. Alright, negative lambda is just a constant, so I'll put that here, and derivative of that is 2 times x minus 6. Right? And partial of these guys with respect to x would be 0. Right? So we set that equal to 0. Right? Let's take the partial with respect to y. Right? So partial of that with respect to y is 0. And here you have a 2 times quantity y minus 19. Again, negative lambda is just a constant. And partial of this is 0. Partial of that is 2y. Partial of negative 25 is 0 since it's a constant. So we set that equal to 0. Alright, so remember that capital F partial with respect to lambda, set that equal to 0, is always going to give us the constraint equation, which is just the x minus 6 squared plus y squared is equal to 25. Alright, so from here, first thing I would do is I'm going to actually cancel out the divide through by 2, so I'm going to just cancel those out. Alright, then I'm going to just move this guy over to the other side so you can see that x is same thing as lambda times x minus 6. Alright, and partial with respect to y, again, divide through by 2. We have 2 here, we have 2 here. And then we have y minus 19 is equal to lambda times y. Alright, then let's look at the function f of x comma y closely here. I'm going to actually try to rewrite, let's see, we want to minimize f of x comma y, right? Here, so if you have x squared, x is same thing as lambda times x minus 6. So this is same thing as lambda x squared would be. So lambda squared x minus 6 squared, right? And here you have y minus 19 squared. So y minus 19 is lambda y. So it's going to be just a lambda squared y squared, right? Which is just same thing as lambda squared times quantity x minus 6 squared plus y squared, right? And but we have seen this expression. We know that since you are on the circle here, so it's x minus 6 squared plus y squared is equal to 25. So this is actually equal to 25. Alright, so we just need to, so this is going to be simply 25 lambda squared is the f of x comma y value. Alright, so what we can do is, let's see, we just need to find the lambda value. Alright, so let's try to find lambda. Alright, so here, from here, I'm going to actually try to solve for x. Alright, so this from here we have, x, I'm going to put the lambda x over here. So it's a 1 minus lambda x, which is equal to negative 6 lambda. Right? So which means that x is going to be negative 6 lambda over 1 minus lambda. Right? So it doesn't look very nice. But here, so I'm going to solve for y again. So it's going to be 1 minus lambda y. Right? So put that over here. Put 19 over here. So it's going to be 19 here. So we have y is equal to 19 over 1 minus lambda. Right? So we got that. Then what we're going to do is we're going to just plug these guys into this equation here and see what we can get. Right? So from here, right, so x is negative 6 lambda over 1 minus lambda minus 6 squared plus y is 19 over 1 minus lambda squared, right? And this guy is supposed to be equal to 25, right? So this equation will we'll be able to find the lambda value, right? So let's find that. So we just need to find the lambda squared, right? So this is going to be, if you square that, you're going to get here. Alright, take the common denominator. Actually, why don't we take the common denominator? Yeah, so take the common denominator, right? So 6 is going to be the same, negative 6 is going to be same thing as negative 6 plus 6 lambda. So you have a negative 6 lambda, but you have a minus 6 plus 6 lambda, right? So you can cancel out those guys, and then we just have to square that. Alright, so here, then you have, let's see, 19 squared. What's 19 squared? So 19 times 19, 81, so 9, so it's a 1, 7, and 1, 9, so it's a 1. I should have memorized this. Let's see, so that's 6, and then you have a 361, right? Alright, so 361, and let's see, we have 361 over, let's see, actually there's a square there. Let's see, I'm gonna have to erase this. Alright, so you have a 361 over 1 minus lambda squared is equal to 25. Right? Then let's see, so I'm going to combine this. So you have a negative 6 squared would be 36. 36, so it's going to be 397 over 1 minus lambda squared is equal to 25. Alright, So we're gonna get, let's see, we try to take the reciprocal of both sides. So you have 1 minus lambda squared over 397. Alright, so this is going to be equal to 1 over 25. Right? Then multiply both sides by 397. We get the 1 minus lambda squared is equal to, let's see, 397 over 25. Right? Then take the square root of both sides. So we're gonna take the square root of both sides. We get the 1 minus lambda is equal to plus or minus, I don't know if this is a nice number, square root of 397 over 25. Right? Then we're looking for lambda, so we have lambda is going to be, right, lambda is going to be 1 plus or minus square root of 397 over 25. Right? So we want to find lambda square, so let's see, we want to make it as small as possible, so I'm going to take the negative version. So you can see that, let's see, this is going to be 25 times 1 minus square root of 397 over 25, right, squared. Right? Let's try to get this number. Right? So I'm going to open up GeoGebra. Alright, so we need to get this value here. Let's see, did I mess up? Oh, actually, I messed it up, so I didn't take the square root. So this should be 5. Instead of 25, that's 5, that's 5, and that's 5. Alright, sorry about that. Alright, then you see that, let's see, 300. Alright, so GeoGebra, and let's see, we want to find that, so 25 times 1 minus, right, square root of 397 and divide by 5 and squared. Right? Right, then we want to know the let's see, 3 decimal places. Whoops. Right, so it's at 222.751. So let's type it in. Right, this came out to be 222.751. Right, so let's double check. Submit for testing. Alright, actually I forgot to take the square root because this is the square of the distance, so the answer should be square root of this answer. So it's a square root of a here. Alright, so it came out to be 14.925. Alright, so I have to put that in. 14.925. Alright, so let's submit for testing. Alright, it came back and it looks like we got this one correctly. Alright, that's it. I hope that this was clear. Alright, so we got that, about the 200. So let's get this value. 222.751. So 222.751. Alright, but this is the square distance. So in order to find the distance, distance is going to be square root of that value. So it's at 222.751. Right, so that's how basically got this value right there. Right, that's it. I hope that this was clear.